This is page 2 of the review, 14.1, 14.2. Page number 2. We're going to graph. Now as we look here, we see that the amplitude is 1. The A value is -1, but the amplitude is 1. The B value is 1 because that's the value in front of the parentheses. The H value is pi over 3. It's always opposite of what's written there. And the K value is -3. So we'll calculate the period, which is 2 pi divided by B, 2 pi divided by 1. We'll calculate the increment, which is the period divided by 4, 2 pi divided by 4, which gives us pi over 2. So we can come down here. We always start at 0, then we go to pi over 2, then to 2 pi over 2, 3 pi over 2, and 4 pi over 2. We can reduce those later. For a sine graph, this is reflected. It has a negative, so it's going to be working its way down. A sine graph always starts at 0. Then it goes to its, in this case, minimum, back to 0, up to its maximum, and back to 0. Now we would sometimes graph that right now. But if you notice how the H value of pi over 3 is not very friendly with pi over 2. So we're going to have to do some math off to the side to calculate this. And we'll write one graph in here. This doesn't happen often, but in this case, this is how you can handle it. We're going to take our pi over 2, that's this value, and we're going to translate it to the right, pi over 3. We need to make common denominators. And we get 5 pi over 6. So this becomes 5 pi over 6. The next one is pi. And we're going to add pi over 3. We need common denominators. So we get 4 pi over 3. Look at how this is really 8 pi over 6. So that went up by 3 pi over 6, which is really pi over 2. So it did climb by the same increment. Then we're going to take our 3 pi over 2 and add our pi over 3, get common denominators. And we get 11 pi over 6. And then our last one is 2 pi. Add our pi over 3. Get common denominators. And we get 7 pi over 3. And then maybe we also need to step back to 0. It's going to be translated pi over 3 to the side also. So there's our pi over 3. Now if you look, this went up, if we call this 2 pi over 6, this went up by 3 pi over 6 to get up to 5, which is only pi over 2. It went up to 8 pi over 6, which is 3 pi over 6 more, which is again the increment. Back up from 8 to 11 is 3. from 11 to 14 would be 3. So it's all going up by the same amount each time. On this side, it's translating 3 down. So we're going to go 3 down here. We're going to go 3 down from this number, 3 down from 0, 3 down, and subtract 3. So we're going to have a new midline at y equals negative 3. It's always y equals k. It's always your k value. So our new scale here is going to be pi over 3, 5 pi over 6, 4 pi over 3, 11 pi over 6, and 7 pi over 3. Our sine graph is going to drop rather than increase. So this is your negative 3. This is negative 4. So you're going to go down by 1, back up to 0, to negative 2, and then back to 0 again. So your sine graph is going to look just like that. Y equals negative sine x minus pi over 3 minus 3. That's a tricky problem. The scale and the translation, the increment and the translation did not work, so we needed to do some special math on the bottom. This equation, there's something tricky about this one. We don't usually have it in this order. Let's rewrite this. This is a positive 2. And that positive 2 we typically like to have at the end. So it's a graph with a reflection translated 2 units up. So we're going to look at the period, 2 pi divided by b, and our b value is 2. So we get pi. The increment is the period divided by 4, so that's pi over 4. Now our pi over 4 increments and our translation of pi over 2, these can work nicely with each other. Pi over 4, it takes 2 of them to match that. So we won't have as much difficulty this time. So 0, this is pi over 4, this is 2 pi over 4, 3 pi over 4, and 4 pi over 4. A cosine graph starts at its maximum, but this is reflected, so we're going to say the minimum. Negative 1, 0, positive 1, starts at negative, goes to here, back to 0, and then negative 1. So looking at our graph, we're going to have pi over 4, we're going to have pi over 2, 3 pi over 4, and pi. We'll start at negative 1, then we'll work our way up to 0, to 1, back to 0, negative 1. So our cosine graph will curve right through here, and we like to label that. Y equals negative cosine of 2x. The 2 shrank, a vertical shrink, by a factor of a half, always a reciprocal of your b value, and it has an amplitude of 1. Then we're going to take each of these points and we're going to translate them pi over 2 to the left. That's pi over 4. That's pi over 2. And then we go 2 units up. And then we're going to take our next point and we'll go over pi over 2 and up 2 units. Pi over 4, pi over 2, and up even higher. Pi over 4, pi over 2, pi over 4, pi over 2. And we draw in our nice smooth line. We should always put in our midline, which is y equals 2. Label our graph. Y equals negative cosine 2x plus pi over 2 plus 2. Our next graph, we're going to treat it the same way. We're going to put the negative cosine of x plus 3 pi over 2 and a positive 3. So our period is 2 pi divided by b gives us 2 pi. So our increment is 2 pi divided by 4, which is pi over 2. When we translate over 3 pi over 2, that works very well with our increment of pi over 2. So we have 0, pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. Cosine graph. It's going to start at negative 1, 0, 1, 0, and negative 1. So we'll come in here and we'll graph out negative 1 and 1. Starts at negative 1. At pi over 2, and then pi, and then 3 pi over 2, and then 2 pi. Climbs up, back to 0, to negative 1. Roll your graph through there smoothly, and write your equation of your graph. Negative cosine of x. We get a different color, and we're going to translate our graph. 3 pi over 2's. Well, our scale's pi over 2, so we got to take on 3 lines to the left and still up 3. So 1 increment, 2 increments, 3 increments, because it's 3 pi over 2. And then we're going up 1, 2, 3. 1 increment, 2 and 3, going up 1, 2, 3. So we have our cosine graph with our midline up here at y equals 3. It's always y equals k. And we write our equation. The last graph that we have, we have an amplitude an a value of -2, but an amplitude, an a value of -1/2, but an amplitude of 1/2, a b value of 2. So the period is 2 pi divided by b, which is 2 pi divided by 2. Our increment is going to be the period divided by 4, which is pi divided by 4. Looks like there's a translation horizontally, but no translation vertically. So I'm going to call this, stretch it out a little bit, call that our half, actually a positive half, and our negative half is here. So we'll take our table, start with 0. This is a sine graph. We have our increments of pi over 4. Pi over 4 is a quarter. It takes 2 of these to equal 1/2. So it looks like this might actually slide off our graph, because we're going to have to go 6 over. So we're going to have to turn these into a little bit smaller, I think. It helps to think ahead. So we have pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4. A sine graph, this is reflected, always starts at 0, and instead of going up, it's reflected downwards. So it's going to go down its amplitude, back to 0, goes up the amplitude, and back to 0. So what we're going to do here, we're going to call this guy pi over 4. This guy reduced to pi over 2. 3 pi over 4. And 4 pi over 4, which is just pi. Come down to our half. Let me get those in the right locations. I'm changing my scale to work by the smaller numbers. So we're coming down, up, and finish. So now we're going to translate this. We're going to translate this pi over 3 to the left. Pi over 3 to the left. 1/4. This is 2 quarters. 3 quarters. 4 quarters. 5 quarters. And 6 quarters. And from there, we would have our graph. All those values would slide over that same amount. So this is the equation. Y equals -1/2 sine of 2 times x plus 3 pi over 2. The other graph here was y equals -1/2 sine of 2x. Okay, we're going to write the equation. This is what we're starting with. We're going to translate it up 4 units and reflect it over the x-axis. So what we're going to say is that the a value is 1/4. The b value is still going to be 2. The k value is going to be 4. And there's going to be a reflection. So that's going to put a negative on our graph. So we'll say y equals 1/4 cosine of 2x plus 4 let's see, this says and then reflected by the x-axis, then reflected. So we're going to go up 4 units, flop down 4 units when we reflect this. So we're going to have our graph actually down 4. So our new k value is going to be negative 4. Because we're going to move it up, then we're going to reflect it, which drops it all the way back down. Okay, let's take a look at the next one. We'll take this graph, we're going to translate it 3 units, and then we're going to reflect it. So our a value is 1/2, our b value is 4. We're going to translate this 3 units right. So our h value is to the right, -3. And then it's going to be reflected over the line y equals -2. So our k value is going to be -2, and it has a reflection, so our a value has to be negative. So we're going to get y equals -1/2 sine of 4 parenthesis x minus 3 minus 2. Let's see what that does. That'll take our graph and move down to -2. It'll shrink it up. This is 1/4, right? We multiply by 1/4, so it actually shrinks it. So the whole graph will go through, I believe, pi over 2. Because it's negative, it's going to come down, up to 0, up, and back through. Got a negative. It's going down. It's down there at negative. And then we would actually translate it 3 to the approximately there. Those would be your 2 graphs. Good luck.